All right, so let's now look at carbohydrate absorption. So for carbohydrate absorption, we're going to get the very end of the digestion. So the very last part of chemical digestion where the carbohydrate is broken down to monosaccharide. And it does this at the brush border. So if we look at how just the process of carbohydrate digestion and absorption. You've got your carbs, and it starts in the mouth with salivary amylase. So that's where it starts. Then it goes, and from that, we get polysaccharides. Just smaller polysaccharides, So these aren't, disaccharides are, two monosaccharides linked together. Polysaccharides are just more than two. So it's just, instead of one huge molecule, now we have smaller, big molecules that are polysaccharides now. Nothing happens in the stomach at all. So we go to the lumen of the small intestine. And in the small intestine, we get the pancreatic juice, which turns the polysaccharides that we have into disaccharides. Saccharides. So remember maltose, sucrose, and lactose. Okay. And that, again, that comes from the enzymes coming from the pancreas. All right. Then from there, that's when they end up going to the brush border. And the brush border will have the enzymes needed to break down the disaccharides into monosaccharides. So at the brush border, then we get monosaccharides. So glucose, fructose, and galactose. So that's the process. So what we're going to look at now is what's happening here at the brush border. Okay, so at the brush border, we have our cells, and the cells, of course, have microvilli on them. Make some big cells here. Okay, and down here, so I'm kind of out of room here, but we have blood. Okay. All right. So up here, this is the brush border. This is where the little microvilli are, whatever. So I'm going to label that so you'll know. So this here is the brush border. Okay. And this is where we're going to get, this is up here, we're going to bring in the disaccharides. that we've gotten broken down from the pancreatic juice. So we've got disaccharides, and when it happens, we get disaccharides on the brush border, and we end up with glucose, galactose, and fructose. Okay, so over here again, what just happened? Here's the brush border. We have our little enzymes that bring, or that combine with the disaccharides. Saccharides to monosaccharides, glucose, fructose, galactose. Okay, so glucose and galactose enter the cell through secondary active transport. And basically there is a transporter on the cell membrane called SGLT, sigled, and this is a symport. Okay, and what's going to happen is it's going to move, glucose and galactose are going to move into the cell through secondary active transport. It's going to ride the backs of sodium. So there's sodium out here. And basically the glucose and galactose are going to come in with the sodium. So it's going to come in here and sodium, and then glucose and galactose. And on the other side of the membrane, which here's the other side of the cell, and here's the blood that's right next to it. And basically along here, and you should, hopefully you agree, there's going to be a sodium potassium pump here. Okay, so we're going to get sodium and, well, sodium out, back into the blood, and then potassium will come in. So the sodium comes in, but it's gotten rid of because of the sodium potassium pump anyway. Okay, so sodium is coming in and coming out, helping glucose and galactose come in. Also on the other side of the membrane is another transporter here called GLUT. GLUT2. And GLUT2 brings glucose and galactose into the blood. Okay? Now, fructose, again, doesn't need sodium because For whatever reason, it just passively basically comes through. So there is another little transporter here. It's another glut. It's called glut 5. And it allows fructose to come in. All right, and then fructose will combine with glucose or whatever and ride back through to come in to the blood as well. So then glucose, fructose, glucose, and galactose then end up in the blood. And where do they go? They go to the liver. Okay? So that's basically how the glucose gets into the cell, and then the cell absorbs it into the blood. The small intestine cells, okay, we're getting glucose into the cell, right? But the small intestine cells actually do not consume the glucose. They actually, their fuel is something called glutamine. So they do not consume the glucose coming through the cells to get into the blood. So all of that fuel, all of that glucose is absorbed into the blood. All right. I think that's it. All right, and now we'll talk about protein absorption, very similar to carbohydrate absorption. So we'll go over that.